now we're going to have a look at a parallel circuit, or a circuit with a parallel section in it. So the way that we're going to look at this circuit is this section here is parallel, but this section and this section are in series. So the first thing we're going to do here is work out the total resistance of the circuit. Now to do that, we need to first of all consider the parallel section. And if you remember, the way we combine resistors in parallel is using this equation. So that's going to give us 1 over 12 plus 1 over 6, because the resistance of R2 is 12 and the resistance of R3 is 6. Now 1 over 6 is the same as 2 over 12. Whoops, that's supposed to be a 12. So 1 over 12 plus 2 over 12 gives you 3 over 12. Okay, and then now the problem with that is 1 over R is equal to 3 over 12. Now if we flip that side of the fraction, we get R over 1. R divided by 1 is just R. If we flip that side of the fraction, we need to flip this side of the fraction, so we get 12 over 3. And that gives us then 4 ohms. So the resistance R is equal to 4 ohms. Now that's only this section here. Okay, so we now know that these two resistors can be replaced by a single 4 ohm resistor. So essentially now you've just got a 3 ohm and a 4 ohm resistor in series. So to get the total resistance of the circuit, we're just going to add up 3 plus 4, because you add resistors in series to get the total resistance. So the total resistance comes out as 7. Okay, now the next bit then is to work out the current through R1. So the way that we do that is we use I equals V over R, and we know that the total resistance of the circuit is 7 and the total potential difference of the circuit is 6. So if we do 6 over 7, which gives us 0.86 amps, we now know that there is 0.86 amps is our total current flowing around the circuit. And if you look at it, we're going to get 0.86 amps here as well. Okay, 0.86 amps here. So basically the current, to get the current, you just take the total potential difference of the circuit, the battery potential difference, and you divide it by the total resistance, and that gives you the current in the circuit. Now, when the current gets here, it's going to split into 2. So we don't know the current in each of these branches yet, but what we do know is the current through this resistor here is 0.86 amps. Okay, now the next bit then is to work out the potential difference across R1. So to do that, we just do V equals IR. So we know that the current through R1 is 0.86, and we know that the resistance of it is 3. So 0.86 times 3 gives you 2.6 volts. Okay, so the next thing, we want to work out the potential difference now across R2 and R3. Now, if you remember, when we've got components in parallel, they're going to have the same, each branch will have the same potential difference across it. So essentially, we know that this is 6 volts, and the voltage across here is 2.6 volts across this section. So to work out the voltage across this section, because these two sections are essentially in series, we know that the potential difference of these two sections should add up to the battery voltage, because these two sections are in series. So to work out the voltage of this bit, you just basically take the battery voltage, which is 6 volts, take away 2.6 volts, and that's going to give us 3.4 volts. And that's the voltage across this section here, okay? Because 2.6 plus 3.4 makes 6. All right. Now, remember I told you that the voltage across each of these two resistors is the same. So each of these resistors has 3.4 volts across them. So the answer to part 5 is just 3.4 volts again. Now, part 6. Here we've got to work out the current through R2. So I'll call that I2. So that's going to be voltage over resistance. The voltage we know across this resistor is 3.4 volts and the resistance is 12. So that is going to give us 0.28 amps. And then finally, the current, so that's I2. We're now going to work out I3, the current through this resistor. So that's going to be V over R. So 3.4, because we know the voltage across this resistor is 3.4, divided by 6, which is going to give us 0.57. Okay, now one final thing. These two currents here should add up to 0.86 because all that's happening here is this 0.86 amps is splitting between the two paths, the two sections of the parallel circuit. And obviously more current goes through the lower section because it's got a lower resistance, and less current goes through the top branch because it's got a higher resistance. But they should add up to 0.86 amps. So if we add these two up, total current is going to equal 0.28 plus 0.57, and that gives us 0.85. Now, that doesn't equal 0.86, but no need to panic. The reason it doesn't equal that is because as we've gone along, we've rounded to 2 decimal places, and that's resulted in a rounding error. So if you use the full values from your calculator instead of the rounded values, it would add up to 0.86 amps.